guys, today we're going to start looking at the practice final exam, and so that you have a good study guide at home to practice with. You already have all the answers, but you obviously need to know how to get to the answers if you're going to do well on this test. So that's what we're going to look at today. All right, so here we go. Problem number 1. 6 times the absolute value of negative 4n plus 4 minus 6 equals 18. Okay, so we want to start by getting the absolute value completely by itself first. So to do that, we're going to add 6. So what we're left with is 6 times the absolute value of negative 4n plus 4 equals 24. And then again, if the goal is to get the absolute value completely by itself, we're going to divide both sides by 6 so that these 6's cancel out. So we have the absolute value of negative 4n plus 4 equals 4. And we went through the explanations in a lot of detail when we first learned this. If any of these explanations aren't making sense as we go, just make some notes about it and come in and see me either before lunch or before school or during lunch, okay? So from here, we want to separate this into 2 separate equations. One of them is negative 4n plus 4 equals positive 4, from over here, and negative 4n plus 4 equals negative 4. So we have a positive version of this number, and we have a negative version of this number. All right, so here we go. So now we just want to solve both of these equations for n, and then we will be good to go. So we subtract 4, so negative 4n equals 0. Divide by negative 4. Make sure you all can still see that. Looks like you can. Move that. So divide both sides by negative 4, so n equals 0. And we do the same thing with this one. So negative 4n equals negative 8. Divide by negative 4, divide by negative 4, and we get n equals 2. So as far as the solutions that you're given, the only one that works there is C. Right? Okay, let's go ahead and move on to problem number 2. Number 2 says negative 5 plus x, again, make sure you can see this, negative 5 plus x minus z plus the absolute value of z, and we want to use x is 3, z is negative 4, and that's about it. All right, so here we go. All we're doing with this problem is we are replacing the x with 3 and the z with negative 4. So negative 5 plus 3 minus negative 4 plus the absolute value of negative 4, and then we are going to go through and actually simplify this. So first thing we want to do, if we think PEMDAS, that's the whole thing that we're reviewing in this problem, we start with the parentheses first. So we want to get rid of, we can treat absolute value bars like parentheses, so we're going to leave these alone. Negative and a negative make a plus, and then the absolute value of negative 4 is 4. And now from this step, we can just go left to right. So negative 5 plus 3 is negative 2. So we get negative 2 plus 4 plus 4. Negative 2 plus 4 is 2, and 2 plus 4 is 6. That would be, again, C. All right, let's move on to number 3, another PEMDAS problem. 4 minus negative, I know that looks like it might be a typo, it's not a typo. 4 minus negative 4 over negative 3 plus 5 plus the absolute value of negative 2. All right, so again, PEMDAS. So we actually can get rid of a couple of things here. We have double negatives. When we have 2 negatives right next to one another, we end up changing those to a plus. So it's 4 plus 4 over negative 3 plus 5, that comes out to 2. And then the absolute value of negative 2 is 2. All right, so then we want to go to the next piece. We want to get rid of this division, because again, if we think PEMDAS, division before adding and subtracting. So we get 4 plus 2 plus 2, and 4 plus 2 is 6 plus 2 is 8. So that again is C. It is a coincidence, by the way, that we have gotten C for the first 3 problems. A lot of students I have had in the past have said, well, there's no way you can do C or any letter for that matter over and over and over again, so there must be something wrong here. It doesn't work that way. If you know how to do it, you know how to do it, and if it ends up being C 4 or 5 times in a row, then that's what it ends up being. It's not a big deal. All right, next, I equals PRT, and we want to solve this for R. All right, well, so basically when it says solve for R, that means get R by itself. So we want to do the opposite of what's being done. So we have, if this is what we're solving for, right now we have a p and a t being multiplied by the r. So the opposite of multiplication is division. We're going to divide by p and t on both sides. So we get I over pt equals r. That's it. We don't want to overcomplicate. All right. Number 5, same kind of a concept. A equals LW plus LH plus WH. And we want to solve this one for L. Right? Okay. I'm going to say again, number 4 happens to be C. Do not take that as being anything except for a coincidence. Okay, so we want to solve for L. So here's the deal. We have 2 L's in this right here. And that should be a clue to you that you're going to have to factor in some way. We only want to get one L. We're solving for one of the L's, not 2 separate ones. So we want to start with the things that are furthest away. The thing that I see that's furthest away is this WH, and it's being added. So we're going to subtract WH from both sides. So we get A minus WH equals LW plus LH. And again, what we see here, what I hope we see here, is that both of these have an L in them, which means what we can do is factor an L out. Okay, so we spend a lot of time doing factoring. When we factor the L out, we're left with W plus H. We have A minus WH over here. And now we have, since we're solving for now, we are down to one L, L times, in parentheses, W plus H. The opposite of multiplication is division, so we're going to divide both sides by W plus H. They cancel out. What I'm left with, see that. What I'm left with is L equals A minus WH over W plus H, which happens to be B. We are now no longer in the C category. So there we go. All right. Again, if you have questions, write them down. Let me know. Let's do some separation here. It's my organizational stuff coming out. All right, number 6. Find the value of 2 numbers if their sum is 74 and their difference is 17. It's actually a word problem. So find the value of 2 numbers if their sum is 74. So the sum of 2 numbers is 74 and their difference is 14. So a lot of you, since this is a multiple choice test, a lot of you would look at that and go, well, I can just plug these numbers in and have it work. True. But it's not always going to be that straightforward. So you want to know how to do this by setting up a system of equations and solving. All right. So sum of 2 numbers is 74, difference is 14. That's how that piece looks. Now, what we can do, remember, now that we have all the x's and y's lined up, we can just add these 2 equations together. And when we do that, we get 1x plus 1x is 2x. Those cancel out. 74 plus 14 is 88. And then we can divide both sides by 2. So we get x equals 44. That means the first one of these numbers is 44. Whoops, sorry about that. Okay, now that we have that one of the numbers is 44, we can take it and plug it back into either of these equations to get the other number. So x plus y equals 74. It doesn't matter which equation, since these numbers should fit in both of these categories. But again, we just found that x was 44, so 44 plus y is 74. And then we subtract 44 from both sides, and y equals 30. And those do fit that category. All right, let's see if we can fit one more in. Let's see, I'm looking at the clock, and the class is going to start in about 2 or 3 minutes. This will be a good challenge for us. We can see if we fit this last one in. So we have another word problem. Let me read it for those people who don't have this sitting in front of them. The school that Jimmy goes to is selling tickets for a spring musical. Over here. On the first day of ticket sales, the school sold 5 adult tickets and 6 student tickets. 5 adult tickets and 6 student tickets for a total of $120. We want to set up a system of equations here. The school took in $69 on the second day by selling 4 adult tickets and 3 student tickets. Okay, so again, we want to have a system of equations set up, and we want to see if we can use the process of elimination here. Okay, So if I'm looking at this, if I try to add these together right now, nothing's going to cancel out. Since it's elimination that we're going for, we kind of need something to cancel out. So if I'm looking at this, I notice that if I multiply this bottom equation by -2, what ends up happening, I've distributed to everything. Let's just rewrite this down here. First equation didn't change, so it's still 5a plus 6s equals 120. The bottom one becomes -8a minus 6s equals -138. So now, if we were to go through and add these two equations together, what would happen is we get 5a minus 8a is -3a. The s's cancel out. 120 minus 138 is -18. And then we can divide by 3. -3. So the adult tickets, what are we trying to find here? Find the price of an adult ticket and the price of a student ticket. Okay, so we find that the adult ticket ends up being $6 because 18 divided by 3 is 6. Okay, so just like we did in the last problem, now that we have that A is $6, we can take it and plug it back into either of the equations that we just set up to find the cost of the student tickets, which is S. So I'm looking at the bottom one and going, okay, well, those numbers are a little smaller. Let's plug it into that one. So 4a plus 3s equals 69. So 4 times 6 plus 3s equals 69. 24 plus 3s equals 69. If we subtract 24, there is the bell. And I'm going to finish this problem really fast. So when we subtract those, we get 3s equals 45. And then if we divide by 3, we get that the student ticket is $15. So let's see, adult 6 and student 15, that would be B. All right, so we will continue on another day for numbers 8 through 50. Have a good day.